now it's time for RTB 101. This is the segment where we talk about practical questions to help equip you to share your faith with friends and family more effectively. And today we're talking about a very important question, which is, has evolution been observed in real time? And here to help me talk about that is molecular biologist Dr. Anjeanette Roberts. Welcome back, AJ.
Thanks, Krista. Good to be here.
It's so great to have you here because when we're talking to our non-Christian friends, I think that there is a very common assumption that evolution is a fact and it has been observed in real time, and to express any skepticism about evolution is to almost deny reality. And so I want to talk about, has evolution in fact been observed in real time?
Yes, it has.
Okay.
And so I would quickly qualify that to say that we see evolution happen almost on a consistent basis, whether in nature or in the laboratory, at a microscopic level, right?
Okay.
So at a microbial level, where you're talking about single-cell organisms, or in simple microevolutionary processes.
So what would be an example of microevolution? Is that like genetic changes? Is that what we're talking about?
Yeah, that's right. So it's genetic changes or mutations, and those mutations can happen through normal processes like DNA replication, when the DNA replication machinery makes a mistake. It can happen through DNA repair, which can cause insertions or deletions or inversions or recombinations of the genetic material. And all of those are variations that can then be worked on by natural processes.
So what would be an example that maybe we might know from our everyday life where we observe microbial evolution taking place?
That's right. So microbes are single-cell organisms. They actually can use all of those mechanisms that I just alluded to, but they can also swap genetic information between themselves. And there's 3 different ways they can undergo horizontal gene transfer. And so in nature, we often will observe things like resistance to antibiotics.
Okay.
And that's something that usually is taking place by this genetic information swapping, but it can also happen through these mutation type processes. And also when we see bacteria that haven't, for instance, been able to process or break down plastics before, gain a function of breaking down plastics, it means that they've probably either accrued a mutational change in a gene that was already there, or they picked up a gene from some other microbe that allows them to break down the chemical bonds that are part of the plastic.
And I know that you have a long history working in laboratories, so I'm wondering if you have even observed microbial evolution happening in a laboratory environment.
Well, so we use these microbial evolutionary mechanisms, the microevolutionary mechanisms, all the time to manipulate microbes in the lab. And so we can actually change microbes pretty much at will in the laboratory and make them do things or express genes of our interest. So we use those mechanisms all the time to manipulate microbes in the lab.
So in answer to our original question, has evolution been observed in real time? We have to differentiate what type of evolution are we talking about. Microbial evolution, the answer seems to be yes. But does that then in turn prove the evolutionary paradigm as a whole to be true?
It doesn't, because it's very different mechanisms and very different objectives that have to take place. It's one thing to change a single-cell organism, that when you change that, the entire population of every single-cell organism that comes from that organism is going to have that change. But in multi-cell organisms like us, it's not just enough to accrue a mutation in a single cell or to make a change in a single cell. It actually has to take place in gametes. Those gametes have to be paired with gametes that can also biologically, sexually reproduce an organism. And so the mechanisms are very different. And in macroevolution, we have this hurdle of novelty, really, like where are the actual fundamental changes coming from that account for a change in kind, not just an adaptation of something that's already pre-existing.
So microevolution doesn't prove, like, for example, fish to reptiles.
That's right.
Or dinosaurs to birds.
That's right.
It's on the singular cellular level.
That's right.
And we would accept that. We would say, yeah, that's no problem. That's scientifically verified for the singular cell microevolution, but not for macroevolution.
Right, and I want to make one more distinction here, though, because in multicellular organisms like us, we see molecular adaptation, right? We see the ability for species to sort of adapt to different changing environments. That's something that's called speciation. And in the big story of evolution, the story that uses evolution to account for all of life, they use speciation as sort of a stepping stone between these molecular adaptations and these macro changes, right?
Okay.
And so we would affirm speciation as well, but we still think that that falls short of explaining macroevolutionary changes.
Very good. I think I want to have you back sometime. Maybe we'll talk about speciation some more. That sounds like a whole...
There's a species problem out there. I've actually blogged about it a couple of times.
Very good. Well, speaking of that, I want to encourage people to go check out your blog, Theorems and Theology at reasons.org. Just do a keyword search on theorems and theology, and you can check out AJ's blog posts with these themes in mind, and also follow her on social media on Twitter and Facebook.